Hello everybody and welcome to Intro to Cybersecurity. As we begin our journey into the world of cybersecurity, let's go ahead and explore the fundamentals of hacking. So the obvious question when we want to explore this is, what is hacking? Well, if we look at a boring dictionary definition of hacking, the dictionary goes ahead and lets us know that it is the gaining of unauthorized access to data in a system or computer. Or, used in a sentence, outlawing hacking has not stopped it. So I'm going to argue in this course that the words unauthorized, outlawing, kind of this hooded mentality of hacking, while it's definitely cool and the rich history of hacker culture is very fascinating, it has very little to do with the actual practice of hacking. Hacking, unfortunately, in some ways, is a lot more boring than that. And in other ways, is actually cooler than that, as we'll kind of see as we explore this kind of idea throughout this course. So the natural question that arises beyond, what is hacking is, well, how do we hack? And of course, that is what this course is going to explore. We're going to understand how to hack, not just what is hacking, how to hack. Okay, well, before we can do that, we need to kind of jump into some fundamentals of cybersecurity. We need to really understand the fundamentals of cybersecurity, the fundamentals of hacking, in order to really understand what it means to hack, how to hack. So before we even get to that, right? Before we even get to hacking, we need to kind of go to the beginning. Before we can hack something, we kind of need to have something, right? Something needs to exist for us to hack. And so we're going to begin our journey of the fundamentals at what is programming. So at a very, very, very basic level, programming is this idea of transforming input into output, right? It's kind of an extension of math. We have this idea of we need this thing where we're going to take in input, we're going to produce output. Now, in the case of computer science, right, a lot of us are exploring computer science. How do we do this? How do we perform this transformation from input into output? Well, the answer to that is computation. We take some input, we apply some computation to that input, and that, as a result, produces some output. Now, if we think a little more abstractly, if we build on top of this, we're not really thinking about things in terms of just the raw computation. We have some sequence of instructions that runs, transforms that input into some output. Really, what we're thinking about in general is some system. I'm sure you can think of all sorts of different systems. For example, you're currently watching this video on a computer. It has some sort of computation running under the hood. But really, what are you using? You're probably using YouTube, right? Some sort of system that encapsulates all of that computation. And so we kind of think from a systems design perspective that we have some system that takes in input and produces some output. Now, back to our question of programming. Programming involves understanding how a system operates, making necessary alterations to that system, and thereby generating desired outputs from given inputs. So in the world of programming, right, what we're doing is we're making these necessary alterations to a system, right? We understand the system, we make some changes to that system, and now we're able to produce new outputs from given inputs, right? We can kind of evolve this system with time as we get new features that we need to add, as we realize there's bugs, we need to fix them, right? It's kind of this process of slowly building up this system so that we can encapsulate more of this input-to-output transformation. So let's get back to our question of what is hacking. Well, I would argue that hacking is almost identical to programming. We're just going to remove one step. So hacking involves understanding how a system operates and thereby generating desired outputs from given inputs. So we just entirely cut out that bit about making necessary alterations to that system. We don't get to make alterations to the system when we're hacking. Instead, we just understand the system, and then we generate outputs from given inputs. More specifically, these inputs tend to be unexpected and outputs unintended. So, you just normally use a system, you're not really hacking. When the hacking comes from is this unexpected and unintended. These are kind of key concepts within hacking. you're going to find outputs that are unintended. And in order to do that, you need to find inputs that are unexpected. So this kind of gets at the hacker mindset. It's asking the question, what input will generate my desired output? And this is a very creative endeavor because, normally you use a system and you're going to give it your input into the system. It's going to produce its output. Well, we need to kind of do almost the reverse. We need to think about kind of from first principles, what output am I looking to achieve? And now I need to go and search to see, can I find an input that will actually produce that desired output? And almost certainly, if we're going to be talking about hacking, it's going to be finding outputs that were unexpected from inputs, or finding outputs that are unintended from inputs that are unexpected. Now, back to our original question, right? How do we hack? So in order to hack, you need to understand how a system operates. So let's imagine a system, right? In this case, we're going to be looking at the system of google.com, right? The most popular website as it currently stands. And what do we do to interact with this system? Well, we type in some query, right? We search how to hack. Now, in order to understand how to hack, we need to understand how these systems operate. How does google.com actually make that work, right? It's obviously, you get so used to it, you take it for granted, you kind of can treat it as this black box and just utilize the system. But in order to understand how to hack something, you really need to understand how it works. And that's going to be a very important concept within hacking and within this course. So how does it work when I go and do that? Well, the first thing that happens, if we just look at this, and you don't need to understand this too much, but we're just going to kind of briefly look into the internals of what's really going on here, is our web server is going to make some system call to its kernel. It's going to do an accept system call, for example. And again, the details of this, it really doesn't matter. This is really just to make it clear to you that there's a lot going on under the hood, and hacking stems from understanding this large amount of stuff going on. So we go and we make our Google search. And so our server is currently accepting some sort of connection. And now our browser makes a system call to its kernel and it says, I want to connect. How does this connection happen? Well, we need to use some networking. If we just look at the ARP layer for a second, we need to find how to get to the next link in the network connection. And again, a lot of these concepts we'll explore later throughout this course. We ask the question, who has this IP address? Again, we'll see that when we explore ARP. We'll see that someone says it's at this location. We start up a TCP connection. We do the SYN, we do the SYNAC. The client kernel says, okay, back to the browsers. We've got kernel space to user space. We acknowledge. We say, okay, well now we've got a network connection over TCP established. The web server gets ready to do a read, so it's accepted some connection. It's ready to start reading some data. Well, guess what? The browser is going to get ready to start writing data. It's going to send over a bunch of HTTP. In this case, you can see this get/search q equals how to hack HTTP 1.1 host www.google.com. I know, this is a lot. This first video, we're kind of really getting into the internals. Don't look too much at it. It doesn't really matter right now. We're going to explore all of these things as we progress through this course. We'll see we get an okay. We send an acknowledgement. Guess what? Well, now we sent our HTTP request. The browser said, hey, this is what I want. It wants to now receive that. It gets ready to read. The server does a write. It sends off an HTTP response saying HTTP 1.1, 200 OK, content length, blah, 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 blah. Sends the content. We get that. We say OK. We acknowledge that we've received that. The web server now knows it's been acknowledged. And suddenly we get our results. So this is kind of a deep dive into the internals of what happens when we search for how to hack on Google. And this is just some of the layers of the technology stack. It's a deep technology stack. There's all sorts of different technologies involved. These are kind of a few arbitrary ones that we decided to look at here. We got TCP, we got system calls, and this course will explore these further in depth. So again, I know this is very heavy material, for the first lecture, right? Going so in depth, you might be panicking, but don't worry. That's why we're going to explore it. We got a whole course to get through this. Okay, so we've got our system, our input, we produce our output, goes to the system, makes that happen. And we just kind of saw that how that happened. Now, clearly, right, we got a lot of things going on. We talked about ARP very quickly, we talked about TCP very quickly, we talked about system calls very quickly, we had this kernel thing, we got this browser, we got this server, we got all these things. Well, when we say that we have our input goes into a system and produces output, really, that system is a system of systems. There's a whole bunch of stuff under the hood, all sorts of these things going together, interplaying together. We had ARP playing with TCP, playing with system calls, all these things coming together to make Google work. And the way that we handle this all in our head is certainly as like a user, is we just do abstraction. We don't need to think about all these internal details going on when we make a search request through Google. We just use it. We abstract it away. We say we have this kind of magic website thing that can go find information. The TCP part of it doesn't matter, IP, ARP, none of this stuff matters. Right? We just abstract it away. We have this Google system. It's great. But of course, under the hood, right, we really do have a lot of technologies at play. We got all of these systems interacting. And as we'll see in this course, hacking comes down to really deeply understanding those internals. Unfortunately, there's no easy shortcut in the world of hacking. If you want to hack something, if you want to understand the security profile of something, you need to understand that something. That is going to be critical to hacking. And again, right, we've got this abstraction. All these things are talking to each other. These subsystems talk to each other to produce the broader system. Okay. Now, you might have heard the word attack surface before in the context of cybersecurity. And if we think about it in this model, the attack surface is really just, kind of the surface of the system, right? If we think in this model of input goes into a system to produce output, our attack surface is kind of like, what are all of the ways that we can get input at this system? So we've got a system, it's got kind of some surface, some input surface. There's all sorts of ways that you can get input into a system. The more complex the system, probably the more different sorts of ways that you can kind of send input. And it could be a whole different types of input. It doesn't just have to be HTTP. You might have timing input. You might have all of the websites on Google, right? They're returning, somehow Google is returning these websites. All those websites are kind of producing input into the system, and that's how they ultimately get discovered. There's a lot of input and a lot of attack surface if we think about the system. Okay, so let's analyze kind of an attack surface maybe from this client kernel. So the client kernel before was sending out these ARP requests, sending out these TCP, SYN, ACK, all this stuff. And ultimately your web browser is talking to its client kernel, and the client is then going on to do a bunch of networking. Right, so we saw this ARP who has, and we saw this ARP is at. Now, that worked all fine and dandy, right? We just saw the system operating and we saw a bunch of details of the system operating and everything worked just fine. Everything worked as intended. Now, the question is, in order to understand issues, to understand vulnerabilities, to understand where things can go wrong, the question isn't what happens when things go as expected. The question is, well, what kinds of unexpected things can happen and how does that influence this whole system? So let's imagine, right, before we were looking at a client kernel and a server kernel, let's imagine there's another kernel. There's another host on the network. And what really happens with this ARP is the ARP is responsible for figuring out the next hop, and again, we'll explore this in a later video, but it's trying to find who has an IP address. So it's talking to everyone right next to it and it says, hey, who has this IP address? And it asks everyone next to it who has this IP address. So it works great, right? The server says, well, I have the IP address you're looking for, right? Google.com has some IP address. We say ARP is at, boom, and we're good to go. Okay. Now what happens if this other system, this other entity within our network also says ARP is at. It says, hey, I'm also at that location. This is like some unexpected input, right? This isn't going to plan. Suddenly, maybe this other kernel is being malicious. It's saying, you know what? I am google.com. I am here. And this is going to influence the behavior of the system. So before we kind of really worry too much about like, what if this, what if that, what if this, what if that, right? There's all these different ways that all these subsystems can interact with each other, and you can get input and input and input. What we really need to do, rather than get lost in all of the directions we can explore, is kind of think of a threat model. What are we worried about happening? What are we trying to protect? What cannot happen? What can happen? We need to kind of focus in on what's allowed to happen. We need to produce some sort of threat model. Now, we were talking before about this attack surface, right? And then we have some input, it hits this attack surface, it goes through the system, it hits output, right? Well, it turns out that if we want to kind of do threat modeling, we want to think about all the different directions that something can go wrong, right? We have all these different subsystems interacting with each other, and we might want to model different parts of the system to understand what we're concerned about. So for example, before we were talking about this issue, right, where this other kernel just does an ARP spoof and says, hey, I am at this IP address unexpectedly. And well, this kind of can be a disaster in that suddenly now this other entity, this other kernel, other person on the network is able to start intercepting network data, because this client kernel, as we'll find out when we understand ARP, just listens to this is at response and just says, okay, well, this is where it's at. Let me start talking to this person because I want to talk to this IP address. This person says they have this IP address. Let me go ahead and start talking to them. And suddenly now, because of this simple thing of sending an is at, we're able to start intercepting traffic from this person. This client kernel is now going to start sending me their data. And this, depending on our threat model, might not be good. On the other hand, right, maybe we think of ourselves as having some network, and maybe, you know, we can imagine we've got a secure network, and the only people that can send ARP within our network are trusted people. And then this is just not an issue. We no longer need to consider this in our threat model. However, if we're on public Wi-Fi, it turns out that all these people on the public Wi-Fi, depending on how it's set up, might be able to start doing these ARP is at and start doing these ARP spoofing attacks. So it's really important to think about our threat model. Are we on a trusted network? Are we not on a trusted network? What do we need to consider? Okay, so now you can consider this threat model from any perspective, right? So we might think about it from the web server's perspective. So this client, ultimately, the web browser can feed data all the way to the web server, making some HTTP request, and maybe they send a ton of data. Well, maybe depending on how we design this web server, we might result in getting a memory corruption issue. We might have sent so much data that we overflow some buffer, and suddenly segmentation fault, we crash the server, and that's no good, right? We need to account for these sorts of things in our modeling. On the other hand, maybe we're looking at it from the web browser's perspective, and we're concerned about the web server doing something dumb like sending too much data to us, right? Maybe we design the web browser, everything works just fine. We make normal web requests, we hit all these web servers, we get all these responses, and then suddenly we hit this malicious web server, and it sends me a whole bunch of data. It sends me this unexpected input that my browser didn't think about, didn't account for, and suddenly it's this massive blob of data. And what happens? Well, maybe we crash the web browser. Or worse, but let's just say for now we crash the web browser, and that's not good. On the other hand, you might think about doing threat models from multiple perspectives simultaneously. It might be a chain of vulnerabilities, a chain of exploits, a chain of issues, of a bunch of weaknesses coming together that ultimately makes the system no longer good. So we might have some other web server. And so let's say us as a user, we visit some random, unfortunately malicious web server, and that unfortunate situation is that they trick our browser into now making a request to some web server, and these are kind of both considered together. This malicious web server has convinced me to make a web request to some other web server, and the web server responds, and now we respond to the other web server, and maybe along the way, right, we're thinking very abstractly here, but maybe along the way we just kind of leaked out a bunch of data where the web browser was kind of trusted from the web server's perspective, and this other web server tricked the trust relationship into being violated, and suddenly we're exfiltrating data. So again, we're kind of thinking abstractly here, and this could get complicated in different ways. But this is kind of the general idea. We've got a lot of subcomponents to consider, and we need to consider how all of these things interoperate together. And this is a large responsibility. There's a lot of different ways that systems can interact together in very unexpected ways. Now, one more little example here. Maybe we want to kind of open up, go one layer deeper in the abstraction, right? You kind of think of abstraction as some onion. We peel back one more layer. Well, the web server isn't just the web server. The web server also has some database, and the web server is talking to that server database in order to store and retrieve data. Well, maybe we send this HTTP request that's very unexpected to the web server, we'll say, and suddenly this crazy input that the web server had never anticipated anything looking like this, because maybe no one would ever put an apostrophe in their input. We just didn't account for it. We had a bunch of test cases, they all worked, but guess what? Turns out this unexpected thing happens, and suddenly we might be leaking usernames and passwords from some server database, right? There's all sorts of ways that this can go wrong. There's all sorts of things to be considered. Now, what does this all go back to, right? I think the best way to think about this is we have input, goes into a system, it gets transformed, and it produces some output. It goes through a system of systems. It goes through this very complex, potentially complex thing. The systems get more complex, right? You might have thousands and thousands of engineers all working on this same single system, all building these subcomponents. All these subcomponents are talking to each other. It can become such a mess that, very quickly no single individual can fully understand the entire system. And really, that's kind of a blessing and a curse at the same time. In some sense, it's great that we don't have to think about the whole system at a time. We get to use, as a programmer, abstraction. We get to say, doesn't matter how that works. I can just trust this input-output relationship, connect my subsystem into that subsystem to produce this broader system, and it's great. The issue is when you start looking at how all these really interact, that you might run into issues. So as we said before, right, we have this unexpected input. It goes into this broader system and it produces some output, right? It's just input, produces an output. As some hacker, maybe I want to look at some website and say, what would be great is if I could get the output being all of their usernames and passwords. And maybe that's possible, maybe that's not possible. The question is, right, it's in the implementation of this system. We need to understand the system in order to understand if it's possible. And really, this isn't a situation where you're going to know for sure, really. I mean, there's concepts called like formal verification, where you can know for sure whether or not something's going to happen. But in a lot of cases, this is just kind of unknowable. You just sit there and you explore and understand the system until you understand how different weaknesses might come together to allow you to produce this output that you're interested in. And that is kind of the basis here, right? Is we've got programming. Programming is all about designing this system. We need to understand the system. We kind of make alterations to the system, and we get input to output transformations. Hacking is really no different. You just don't get to alter the system. All you get to do is understand the system and therefore abuse the system.